we're going to do problem number 2, and we want to go ahead and graph and define all characteristics. So in graphing, we want to make sure we find the x coordinate of the vertex, and that's always negative b over 2a. The a value is negative 3. The b value is negative 18. We don't need the c value, but if we needed it, it would be negative 29. Now, b here is negative, so the opposite of b is the opposite of negative 18 all over 2 times a, which is negative 3. So I would suggest making sure you use parentheses, especially when we have negative numbers. And then we can see clearly the opposite of negative 18 is positive 18. 2 times negative 3 is negative 6. So 18 divided by negative 6 is negative 3. So there's the x coordinate of the vertex. And when we know the x coordinate of the vertex, the y coordinate of the vertex is just when we plug in negative 3 for x, we see wherever there's an x, we plug in negative 3. This is kind of a lot of work here. Minus 18 times negative 3 minus 29. So we have negative 3 times 9 minus 18 times negative 3. That's going to be a negative times a negative is a positive, plus 54. 18 times 3 is 54. Negative times negative is positive. And then we have minus 29. So negative 3 times 9 is negative 27, plus 54, minus 29. And now if we are smart here, we can think we can do this. We can combine the negative 27 and the negative 29. Negative 27 minus 29. Well, I take it back. We'll just go ahead and add these left to right. So negative 27 plus 54 is 27. And we still have that minus 29, and 27 minus 29 is negative 2. I think that's actually, if we're smart, we will just do the addition and subtraction from left to right. So we can see here that when the x coordinate is negative 3, the y coordinate is negative 2, and that then is our vertex. Negative 3, negative 2. So I'm going to go ahead and draw the graph over here. I guess I could zoom out a little bit, maybe. Not sure how to do that right now, so I'm just going to go ahead and draw the graph. The x coordinate is negative 3, the y coordinate is negative 2, and we can see here from a being negative, remember we're graphing this function here, when a is negative, the parabola opens down. So we have our parabola graphed. Oh, good. So we can show the whole chart and the graph at the same time. So we know that the domain is all real numbers of every quadratic function. The range, the range is the lowest y to the highest y, low to high. Since there is no lowest y, we call that negative infinity, and the highest y value is right there at negative 2. Y coordinate of the vertex. So, but it also includes negative 2. We don't want to forget to include that. Now, the graph of this function is increasing first. So the y values are getting higher. Y is going up, and then here, y is going down. So we say the function is increasing all the way from negative infinity all the way to that x coordinate of the vertex, which is at negative 3, and the value, the y values are decreasing all the way from negative 3, that axis of symmetry, to infinity. And the slope, we can see the slope initially starts off pretty big positive, and as we move to the right on the graph, the slope actually gets smaller. So the slope is decreasing. The slope gets smaller as we move from left to right. We always read graphs from left to right. We could see there's no x-intercept, so we don't have to worry about that one this time. And we could see that when x is 0, here y is 0, never. Here when x is equal to 0, we can see that the first two terms drop out and we just get negative 29. When we replace x with 0, we get y equals negative 29. So therefore we say that the y-intercept is 0, 29. we have a maximum value. That's the highest y value in the range, -2. There is no minimum value because the graph goes down forever, both directions. The axis of symmetry is x equals -3.